Hi to everyone. In this video, I am just going to discuss about an algorithm as how to pop out the element the data structure stack. Okay. So in the last video, we have discussed about the push operations. In this video, I am just going to discuss about the pop operation. It's a reverse process of push. Reverse process of push means in the push operations, we are just going to insert an element onto the stack, but here we are just going to pop out an element from this stack. So here I am defining the procedure as pop, in which I am passing the argument, the name of the stack as stack itself, and the stack pointer as top, and the item to be popped out is item. Okay. So whenever if you are going to do the pop operations, we should check for the conditions underflow. We have already seen while doing the push operations, we are checking for the condition overflow. While going for the pop operations, we should check for the underflow. What is mean by underflow? Underflow is nothing but when the programmer is trying to pop out the element when the stack is empty. For example, you just consider the stack. Here there are no elements in this stack. It means the stack is empty. If a programmer is trying to pop out the element from the empty stack, means then that condition is called as underflow. Okay, so how can you check this condition? Means you can check it by using the stack pointer, that is the top. So here I am checking if top is equal to 0, then print underflow and return. Once it reaches the conditions underflow, means there is no necessity to do the further actions, because how can you pop out the element from the empty stack? So whenever the top value is equal to 0, means we have to print the message as underflow and we should return the control. That's why here print underflow and return. In case the stack contains some elements as A, B and C. Okay. So in such a case, top value is equal to 3. The topmost element, that is a top pointer, will be equal to 3. So by that time, before popping out the element, at first we should retrieve the element which is present in the topmost place, and we have to store it to the variable item. That's why here we are writing the statement as set item colon equal to stack of top. It means now the top value is 3, means stack of 3. What is the value stored in the stack of 3? C. So C, which will get stored in the variable item. So after storing the data to the variable item, we should deallocate this memory, or else we should remove this element from this memory. That's why here we should set it as null. Before decrementing, we should set it as null. That's why here, just for resetting that memory locations, here I am writing set stack of top colon equal to null. That means there will be no value in this memory locations. So after doing these things, if there is no element, once if we have done the pop operations, means definitely we can decrement the pointer top. That's why here I have written top colon equal to top minus 1. So after popping out the element, since we are decrementing, the value of top is equal to 2. The value of top is equal to 2 and then return. In case if I am just again going to call the procedure pop, means by the time what it will happen here is again it will check for the conditions whether the top is equal to 0 or not, but here the top value is equal to 2. That's why the condition fails. So program control comes to the second statement, in which I am just going to pop out the element B, the B which will get stored in item. Then this memory locations which will be reset by storing null in this locations, and then I am just going to decrement the top value by 1. So that means I will get a top is equal to 1. So yeah, again if I am calling the pop operations means definitely the element A will be popped out, and the top pointer will be decremented by 0. Top pointer which will be decremented by 1. That's why we will get top is equal to 0. So after this condition, if I am just going to again call this pop means it will check for the condition top is equal to 0 or not. Of course, in this situation the top value is equal to 0. We couldn't pop out the element from the empty stack. That's why here we can print the messages underflow and we can return. Okay. So, whenever if you are going to do the pop operations, you should check for the conditions underflow. If that conditions is not at all achieved means, then we can pop out the element. While doing the pop operations, we should decrement the stack pointer by 1. And one more thing, whatever the operations may be of, it may be of a push operations or else it may be of a pop operations, you can push only one element onto the stack at a time and you can pop out only one element at a time. You couldn't push all the elements at the same time, and you couldn't push and you couldn't pop out all the elements from the stack at a time. Okay. So you should do it by one. And now let's see the some differences between the push and pop operations that we have discussed so far. Okay. So I am writing push here and I am writing pop. Initially push is for inserting the data onto the stack, and it's for deleting an element from this stack. While doing the push operations, the top pointer which will be incremented by 1. While doing the pop operations, a top which will be decremented by 1. And next one thing, whenever if you are going to do the push operations, you will check for the condition overflow, and while doing the pop operations, you will check for the condition underflow. And while pushing an element onto the stack, at first you will increment the top pointer as top is equal to top plus 1. Then you will assign a stack of top is equal to item. Okay, here what you are going to do it here is, at first you will retrieve the element. That's why item colon equal to stack of top, and then we will decrement it top colon equal to top minus 1. Just to see the difference, here we are inserting, here we are deleting. Here the top pointer is incremented by 1, here it is decremented by 1. Here we are checking for the condition overflow, here we are checking for the condition underflow. For doing the push operations, first we are incrementing the top pointer, then we are going to store the item onto the stack. Since it's a pop operations, the stack, the topmost element which will get stored in the variable item as first, then only we are going to decrement the stack pointer by 1. Okay, so these are all the basic differences between the push and pop operations. Okay, I hope that everyone got a clear idea about the push and pop operations which is happening in this stack. Okay, so while taking the data structure stack, in which we are just going to do the two operations, one is the push operations and next one is the pop operations. Okay, so this is the concept. In case if you are having any doubt, kindly post your queries. Okay, thank you.